6.5 Indirect Proof and Inequalities in one triangle. The questions we're going to look at answering today are: how are the sides related to the angles of a triangle? And we're going to discuss and figure out how are any two sides of a triangle related to the third side. Core vocabulary that we're looking at is indirect proof, proof, and inequality. What you're expected to learn is how to write indirect proofs, how to list sides and angles of a triangle in order by size, and how to use the triangle inequality theorem to find possible side lengths of a triangle. In an indirect proof, you start by making the temporary assumption that the desired conclusion is false. By then showing that the assumption leads to an logical impossibility, you prove the original statement true by contradiction. What this means is that you take your proof statement and you want the opposite of that. You make it false. So that when you're working through the proof, you reach what's called a contradiction. So you make a statement that it can't be true. And because that contradiction occurs, that means that this assumption is false, so that the opposite of that, which is our original statement, our original proof statement, has to be true. Let me show you what that means. Okay, let's look at this example. We're going to write an indirect proof that in a given triangle there can be at most one right angle. Now the at most means that my limit is, or my maximum, is one right angle. Okay? So our assumption is going to be the opposite of that, so let me write this down. So we're going to assume that it's going to have more than one right angle. So let's just say the triangle ABC has two right angles. Okay, because two would be more than one. Alright? And then remember that the angles in a triangle have to add up to 180 degrees. It's called the triangle sum theorem. Okay, so I know that the measure of angle A plus the measure of angle B plus the measure of angle C has to add up to 180 degrees. Okay? We want two right angles, so we're going to let angle A and angle B be the right angles. Okay? So that means that the measure of angle A is equal to the measure of angle B, which are both 90 degrees. Okay, so by substitution, I'm going to plug that into this triangle sum theorem. I'm going to have 90 plus 90 plus the measure of angle C has to be 180. Okay, combining like terms or adding, that gives me 180 plus the measure of angle C is equal to 180. Now when I subtract the 180 from both sides to get the angle C by itself, I end up getting that the measure of angle C is equal to 0. Okay. That's where my contradiction occurs. I cannot have an angle in a triangle be 0 degrees. So this right here, that conclusion is false. This cannot be true. I cannot have an angle of 0 degrees inside a triangle. Okay. So if I have more than one right angle, I don't have a triangle, which means that this proof statement, the triangle ABC can have at most one right angle, has to be true because this assumption gave us an impossibility. These are the steps used in writing an indirect proof. You might want to take a minute to write these down and have them in your notes. Okay, let's start by practicing what the first step in an indirect proof is. Okay, we're going to take a statement and we want to assume that the opposite is true. That's our first step. So here's our statement. It says not all the students in a given class can be above average. So we want to make an assumption, a temporary assumption, of the opposite of this. So the opposite would be in a given class, all the students are above average. Okay, with this example, here's our statement. No number equals another number divided by 0. The first step in the indirect proof would be to write the opposite statement. So we would want to assume that there is some number A that's equal to another number divided by 0. Okay? want to assume that this is true, that it does happen. Okay, next we have what's called the triangle longer side theorem. And what that says is if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So let's look at this. So if I have this triangle, ABC, and let's say that side AB is 8 units long, side BC is 5 units long. Okay, because the length of AB is greater than the length of BC, that means this angle opposite, so this would be opposite, so C would be opposite the 8, and A would be opposite 5. Okay. Since C is opposite 8, that means that angle C, the measure of angle C, has to be greater than the measure of angle A. Okay. So the longer side is across from the bigger angle, and the shorter side is across from the shorter angle. Okay, the triangle larger angle theorem says that if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So it's kind of backwards from the triangle larger side theorem, because in this case I'm giving you the angles and you have to determine which sides are bigger. So because the measure of angle A is greater than the measure of angle C, okay, you know the opposite side, which is BC, so the length of BC has to be greater than the length of the opposite side of the 30-degree angle, which is AB. Okay? So the length of BC has to be greater than the length of AB because of the angles. In this example, we want to list the angles of the given triangle from smallest to largest. So my smallest side would be this side AB. So across from that would be angle C. So I know angle C has to be my shortest. The next side length is the 8. That's going to be opposite angle A. So I know angle A is my middle angle. And then 10 is my largest length. So that means that angle B has to be my largest angle. Okay. All right, let's try another one. This triangle DEF, I want to list them in order from smallest to largest. So my smallest side is EF. That means my smallest angle has to be D. Remember, we're looking opposite. The next biggest side, or next smallest side, is the 15, which is DF. And opposite or across from DF is angle E, which would mean that angle F has to be the largest angle. Okay, this triangle inequality theorem, it says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if I look at this example, my triangle just kind of as a reference, that means I can pick any two sides, and if I add those lengths, it has to be greater than the third side. So that means that if I take the length of AB and I add the length of BC, that has to be greater than that third side AC. And it doesn't matter if I pick any combination of sides, this theorem is still going to be true. So I could take BC plus AC, the length of those two, and that's got to be greater than the length of AB. And then the third combination would be if I take AB plus AC, that has to be greater than the length of BC. If this is true, then I have a triangle. Okay, so let's use this theorem. Is it possible to make a triangle with the given side lengths? So if it's true, that means any combination of these numbers, if I add two of them, it has to be greater than the third side. Looking at this, I see right off the top that 3 plus 12 is actually 15, and I know 15 is not greater than 17, so my answer would be no, this does not make a triangle. Okay. With this example, we're looking at 5, 21, and 16. Now, is it possible to add any of these two and come up with a number greater than the third side? So if I start with 5 plus 21, that's 26, and obviously 26 is greater than 16. And then if I take 21 plus 16, that's 37, and I know 37 is greater than 5. Okay, but what if I take 5 plus 16, I get 21. 21 is not greater than 21, it's actually equal. But the theorem said it had to be greater than. So this one would still be no, because 21 is not greater than 21. Okay, it would have to be greater than, not equal. All right, with this example, we're going to use the triangle inequality theorem, but we're going to look at it a little differently. We're going to put a little twist on it. A triangle has two sides with lengths 5 inches and 13 inches. Describe the possible length of the third side. So basically, I'm giving you two sides, and you have to figure out what's the possible range or possible values for the missing third side. So to do this, let's kind of start by drawing out some triangles. Because there's two different possibilities. One of them is that x is one of my shorter sides, so 13 would be my longest side. And so I'd have, let's say, the 5 here and the x here. The other possibility is that the 5 and the 13 are my smaller sides, and x is the longest side. So I would put the x here, and then let's say I'd put the 5 here, and the 13 would go here. As an example, these are just kind of references so that I know what to do. The triangle inequality theorem tells me that I can add the two smaller sides, and they have to be greater than the third side. So here I would do x plus 5 would have to be greater than 13. And then on this inequality, I would say 5 plus 13 has to be greater than x. Okay, so simplifying this out, if I subtract 5 from both sides, I would get that x is greater than 8. Using solving this inequality, I'd get that 18 is greater than x. Right, and I can flip this if I want. I could say x is less than 18. Right. But to kind of help you see, okay, well, what do I do with both of these? If you kind of draw a number line here, and let's just say that 8's here and 18 is here, what do these two things tell you? Well, this one tells you that x has to be greater than 8, so you're going from 8 towards the right. This one would tell you that x is less than 18, so you're taking from 18 and you're going this direction. All right, so your inequality, if you're graphing that, is actually going to be all the numbers between 8 and 18. So to kind of merge these two inequalities together, you would say that 8 is less than x less than 18. Okay. This would be the possible values